Here we are going to go look into some of the image properties. So we have this original image, which is the color.jpg file, and let's see what it looks like originally without me making any changes. So the image comes out to be looking like this, and we will see how we can extract some of the important characteristics and properties of this image. The first thing we want to look into is the pixel level. So if we were to access a particular pixel in that image, we would call it by img. Now img is nothing but the image, and this is in form of a matrix in OpenCV. So you can access a particular pixel in that image by just giving the location of the x and y, the row and the column in that image. So say for example, if you were to access the image at location 100 by 100, let's see what it comes to be, and we will print this pixel value onto the screen. And instead of having the wait key over there, we will call it after the print pixel, because we do want to print the pixel as well as show the original pixel in the same time. So we save this, we go back to our command prompt, and we run this. Let me make this a little big, the font, so that it's comfortable reading. Okay, so let's read it again. So we can see that we were trying to access the location of 100 by 100. 100 by 100 is probably somewhere around here in this region, and the pixel value in that location seems to be 136, 130 and 35. So this is the blue, the green and the red channel in our image. So the value of blue is 136, green is about 130 and red is 35. So that 100 by 100 is somewhere around this, and I'm going by looking into this x and v location. So it's giving me the horizontal and vertical value in that particular file. So 100 by 100, I'm not able to pinpoint the exact location, but 100 by 100 is somewhere around here, and that's what we're getting as the pixel value. So I'll press the escape button now and close this application. Let's go back. So that is in order to find the original pixel value. Now if we were to access just the blue pixel, and I was only interested in accessing the blue pixel, so how would we do that? So an image is of course represented in form of a matrix, and the color channel is given by the particular value in our pixel. So if we were to access just the blue pixel value, we would put down, say, 100 by 100, which is the horizontal level, 100 by 100, the vertical level, and the third value in our matrix is the channel. Notice how we were accessing only two variables, the horizontal and the vertical, in order to get the pixel value. But now in order to find out the exact particular channel, we are putting down a third variable in our matrix, which is now we are putting it as 0. And the reason we are doing that is because the image is form of 3 channels. Since it's a color image, it has 3 channels: blue, green and red. And if we were to access just the blue value, we would need to put down 0 in this case. But if we need green, we would put down 1. If you would need red, we would put down 2. So that's how you can access the particular channel level pixel. So in this case, let's see how the blue pixel looks like. And we already know what the blue pixel looks like when we printed this. So this will just validate the information for us. And let's print the wait key as well, so that we can see the image while we're looking at the pixels. Let's go back, let's print, let's run the Python application. So you can see that 136.35 was the original, just the pixel level value, And now 136, we are specifically asking what is the value of the blue channel in that particular pixel, and which is 136, which we can verify from here. Now let's come back and first close this application, go back to our code and see how we can change the value in that particular location. So let's uncomment this portion of the image of the code. Now we are working on the 100 by 100th location in our image, and let's see what this looks like. 100 by 100 and 100 by 100. So we're changing the particular location of that 100 by 100 pixel, and instead of having the 130 as the blue, 136 as the green, and 35 for red, we are changing them into 255. We are changing all the three channels: the red, the blue, the green, the red. So this, it starts with here. The first is blue, green, and red. So we're changing all the three channels to 255, and we will ask to now print the image. Again, let's remove our wait key function from here, and let's put it down here and save this Python application. Go back to our command prompt and run. So now you can see that the 136, 130, 35, and 36. So that has been now changed to 121, 102, and 21. Let's go back to the code. And the reason what we need to do is, I did not change the 100 by 100 location while printing. That's the reason we are getting some garbage value onto the pixel. Let's come back, let's reprint this and see what it does. So you can see 136 to 130, 35, which was the original pixel level, is now changed to 255, 255, and 255. So I did initially, I was not printing the 100 by 100th location, but after we changed it, we can now see the pixel value is now 255. Now you might notice that's not making a big difference on the image, because this is just one pixel in this plethora of pixels. So this image is composed of quite a bit of pixels, and it might be ranging anywhere in the 30 to 35 or 40,000 ranges. So many pixels available, and you're just changing one particular pixel in this point. So it's very hard to see from a visible eye perspective, but if you were to just maximize that particular region where this image is, you would find out where your 255, where is that pixel which we changed to 255. So let's look into how we can go back to the code and see what other properties that we have to access. Let's remove the wait key function from here. Let's uncomment these lines, and now we are trying to print the shape of the image. So this is one of the important properties, because many applications require this, and especially when you're working on different data types and different images, and you're working with a couple of other images which may be of different sizes. So it is important for us to know what the height and the width of the image is, and you can do that by invoking image.shape command, and this is part of the OpenCV. So you can just print image.shape, and it will give you all the three image information. Now the height, the channel, the width, it is given by this particular location. So when you print shape, it gives you three information. One is the height, the second is the width, and then the channels. So it gives you information about all the three, and it'll give you what the height is, the width is, the channel is, and it would be the same as by given here. So we can also just for the sake of doing it, we can print again the height, the width, and the channels just to see the difference. And let's save this. Let's go back to our command prompt. I'm going to quickly clear this so it's easily visible for us, and we print it now. So you can see that the last portion, which is 476,643, it is defining the height, the width, and the channels. We can pinpoint our mouse at the bottom right corner of the image, and you can see, just notice this particular part, and you will see that the X value is being given as 475,634, so which is a little bit closer because I'm not able to point the most last pixel of the image, but that is where it is giving us that information with. So it's giving the height and it is giving the width of this image, and also printing the channels, the number of channels present. Now since it's a color image, the channels are 3 in our case. Let's close this. Let's go back to our Python application and look into the other property. You know what, before we do that, just because we're going to be doing the region of interest, let's see what this is, and then I will go into how to access that particular location. So let me uncomment this and look into the other property, which is called as region of interest. Now what is this? We've seen the image, and we've seen the image is a big image, which is about 640 by 430 something, and it's a very big image. And if we were to be interested in a very small region of that image, say for example the face, or the particular location of the body, if you were doing face detection or object detection, and in your application you're only interested in finding the location of the face or that particular object that you're trying to access, this region of interest will help you. And it's a very important property. This will come across in many of the applications that we are going to be running across in the future. So region of interest helps us in identifying or accessing only that particular location of the image. So let's see how we can access this, and we go ahead and save this. We print this and we try to access this. So it's giving us some random region of interest because the value of the pixel that we have given it, it's some random thing at the moment, but let's change that. And let's see if we were to access only this particular location. So we were only interested in identifying the face in this image. So we can see that the starting, if you look at the point, the pixel value in this, notice the X and Y coordinate here, and you can see that the bottom left corner is 47 by 94, and this particular region is 261 by 351. So let's go back here. We'll put down as 47 by 94 in this case. (94) 47 and the region here is 276 and 372. Let's go back here. 276 by 372. I might have done it the other way around, because you need to first put down the Y coordinate here. And let's print this. So let's close this image here. Let's go back to our Python application. Let's save this thing. So we are now going to print, or just show us the location of this particular region, which is given by 94 by 372 and 47 by 276. Let's show this, and we can see that it has extracted the face from the image. So how we are doing this is, this particular region, we need to find out the y coordinate of this guy, of this particular pixel value, and the y coordinate of this particular value. So we need to provide these two values first, and the x coordinate of this value, then the x coordinate of this value. So you're just basically showing that I am interested in the region which is bounded by the x and y of this location and the x and y of this location. So it is simply giving us that particular region that we are interested in. So this goes in a long way in face detection, object detection, and many other applications, and it's a very important property. OpenCV and Python allows us to do it very easily. I remember using it in C++, and I had to use region of interest, and we had to do quite a bit of calculations in order to identify the region of interest, and in order to obtain or extract the region of interest that we were looking for. But Python and OpenCV has made it very easy, and this is how you can access the region of interest. I'll press the escape button and we'll go back into the code. So with that, we went through the region of interest, and now we will see how we can access the channels. So let me comment out everything here until here, so we can just see the original image, and we will see the channels. So we know that the image is made up of 3 channels, and if we were interested in only accessing the blue, green, and red channels, this is how you would be doing. You're just specifying the image variable, and you're telling that we need everything within the horizontal axis, we need everything within the vertical axis, and we need the channel 0. So everything that is comprised in the image in just the blue channel should be taken out and given it to the blue channel. So this is nothing but another form of region of interest, but as a whole, taking the image and accessing the blue channel only. That's with the blue channel. And then comes the green channel. If we were interested only in the green channel, so we are again saying everything that is comprised in the green channel by 1, the channel is 1, and it's giving us as green. Red, similar case, and here you're only specifying the red channel. So we're printing all the 3 on the screen. We are using the ImShow in order to display the images for us, and we're using the CV wait key so that ImShow function can work. We'll save this, and we will go back to our code. I've just cleared it, and let's run this. So you can see this is the red channel, and then the green channel, the blue channel, and our original colored image. Now you may think, why are we looking at a black and white color, and why not a blue color for blue, why not a red color for red, or a green color for green? The reason you're not seeing those 2 colors is because a color is defined by 3 colors. A pixel value is defined by 3 pixels, and blue, red, and green, they combine together and then only give you that color in an image. But a blue channel by itself, or the blue color profile by itself, the red color profile by itself, or the green color profile by itself does not comprise or does not carry the information about a color. So separating all of the 3 will not give you that color profile, but you can access just the blue channel, and this is an interesting feature which helps us if you're doing certain types of tracking. If you're doing a color detection, or you're doing blob tracking, where you need to and you have a colored object, say you're looking for an orange colored ball in an image, and you were only interested in extracting the orange color, this particular feature would be helpful. But this is just showing us how we can access all the 3 channels. So I'll close this now.